Forget concept cars. Forget flashy commercials. Forget those coming soon promises that somehow never arrive. A few days ago, something happened in China that quietly made some of the biggest names in the auto industry stop and pay attention. Not because of a futuristic sports car or a billion-dollar factory, but because of a plain silver box sitting on a stage. Sounds boring, right? Well, that's exactly what everyone in the room thought too. On July 16, 2026, inside Geely's research center in Wuxi, China, journalists walked into another product launch expecting the usual corporate presentation. A few slides, some big claims, polite applause, and everyone heads home for lunch. Even one reporter in the audience was scrolling through his phone before the event began. That's how little excitement there was. Then, Geely executive Li Qinghai walked onto the stage. No dramatic entrance, no hype video, no loud music. Behind him sat a silver box about the size of a carry-on suitcase. Honestly, if someone told you it was an office server or an industrial air conditioner part, you'd probably believe them. Then he said one number, 93.8%. For 2 seconds, nothing. The room went completely silent. One pen hit the floor. Someone quietly whispered, "There's no way." Suddenly, every phone in the audience was recording, because everyone there understood what most people watching this video probably don't. That number wasn't about horsepower. It wasn't battery size. It wasn't driving range. It was efficiency. The number engineers obsess over because it determines how much of your battery's energy actually reaches the wheels instead of disappearing as wasted heat. And if Geely's claim is accurate, it could represent one of the biggest leaps in EV engineering we've seen in years. Nobody likes paying for something they never get. That's exactly how electric cars work today. Every EV loses some energy before it reaches the wheels. The question is, how much? And that's where this story goes from interesting to something that has engineers at companies like Tesla, Volkswagen, Ford, and GM quietly doing math they weren't expecting to do. Because once you understand what that 93.8% really means, you'll see why this tiny silver box might end up changing the next generation of electric cars. So, what exactly is inside this mysterious silver box? At first glance, it doesn't look like anything revolutionary. But here's the twist. The biggest innovation isn't a brand new motor or some magical battery chemistry. It's how everything has been combined into one system. Think about how most electric cars are built today. Inside a modern EV, you don't have one main power unit. You have a collection of separate systems scattered throughout the vehicle. The electric motor, motor controller, battery management system, onboard charger, DC-DC converter, thermal management hardware. Each lives in its own housing, connected by a maze of cables running across the chassis. It works, but it's also complicated. More parts mean more wiring. More wiring means more weight. More connections mean more places where something can eventually fail. Instead of redesigning one component, Geely decided to rethink the entire layout. Their engineers combined 16 different systems into a single integrated unit, including 12 hardware systems and 4 intelligent software layers. This isn't just a catchy marketing name, it reflects how many separate systems have been merged into one package. The result? Around 180 individual components simply disappear. That's 180 parts that no longer need to be manufactured, assembled, inspected, or replaced years later. High-voltage wiring is reduced by roughly 30%, while low-voltage wiring drops by around 15%. Less wiring also means less weight, easier assembly, and fewer potential failure points. And that single magnesium alloy unit weighs only about 75 kilograms, replacing what used to be an entire network of separate electronic modules. Now here's where things become even more interesting. A cleaner design doesn't just save space, it can improve performance too. The Thunder Power unit comes in 2 versions. The standard model produces 245 kilowatts, which is already competitive. The all-wheel drive version increases that to 425 kilowatts, or roughly 570 horsepower, using an 800-volt architecture designed for ultra-fast charging. That allows the Galaxy TT sedan to accelerate from 0 to 100 kilometers per hour in just 3.8 seconds. Performance that's normally associated with high-end performance cars, not a mid-size electric sedan. But engineers weren't just talking about acceleration. They started calculating something much bigger: Geely claims the Thunder unit delivers an impressive power density of around 16 horsepower per kilogram. Based on the unit's weight, some engineers estimated the integrated design could theoretically support outputs approaching 1,200 horsepower. Now, to be fair, Geely hasn't fully clarified whether that figure applies to the complete integrated system or only specific motor components. Even so, the officially confirmed 570 horsepower version already outperforms the power-to-weight ratio of many production EVs from Ford, Volkswagen, and General Motors. And if the integration works as efficiently as Geely claims, this isn't just a better electric motor. It could represent a completely different blueprint for how future EVs are engineered. Big claims are easy. Anyone can put impressive numbers on a PowerPoint slide. The real challenge is proving those numbers outside the presentation room. Geely knew that. So instead of ending the launch with flashy animations and dramatic music, they took the Thunder-powered Galaxy TT somewhere much tougher, a place where engineering either performs or gets exposed. Their destination was Qinghai Lake, one of China's highest altitude endurance routes. Thin air, changing temperatures, and demanding terrain make it a serious test for electric vehicles. It's the kind of environment that pushes batteries, motors, and cooling systems far harder than a smooth city road. And this time, Geely didn't test the car alone. Guinness World Records officials were present on site, using their own timing and measurement equipment to verify the results. The first result immediately grabbed attention. The Galaxy TT recorded an energy consumption of just 8.20 kilowatt-hours per 100 kilometers during the endurance run. For comparison, many electric vehicles consume significantly more energy under normal real-world driving conditions. If these numbers translate beyond the test environment, it could mean noticeably lower operating costs and longer driving range from the same battery. That earned Geely its first Guinness World Record, but they weren't finished. Next came a demonstration that sounded more like something from a professional drifting competition than a production car launch. Two Galaxy TT sedans were driven side by side in a continuous synchronized drift. Not for a few corners, not for one lap, for 46 kilometers without stopping. Anyone familiar with performance driving knows drifting creates enormous heat. Tires wear rapidly, motors work continuously, and cooling systems are pushed to their limits. Sustaining that kind of stress for long periods is extremely difficult. Yet according to the demonstration, both vehicles completed the entire run without overheating or mechanical failure, earning a second Guinness World Record. Now here's where the story becomes more interesting. Not everyone in the automotive industry immediately accepted every headline. Some engineers pointed out that the 93.8% efficiency figure comes from China's CLTC testing cycle, which differs from testing standards like the EPA in the United States or WLTP in Europe. Others also noted that while the Guinness records verified the demonstrations, the tests were conducted on Geely's own selected course under company-controlled conditions. That doesn't mean the achievements are fake. Far from it. The 16-in-1 integrated power unit is real, and independent journalists have physically examined the hardware. The engineering changes, fewer components, reduced wiring, and the compact design are genuine innovations. But one important question still remains unanswered. Can these impressive results be reproduced by independent testing labs outside China? Because until that happens, the world's automakers are caught somewhere between curious and very, very cautious. So where does all of this leave the rest of the auto industry? Interestingly, the loudest response wasn't criticism, it was silence. When a company announces something this ambitious, competitors usually respond with their own breakthrough, a press release, or at least a statement explaining why their technology is different. This time, almost nothing. And sometimes, silence says more than a headline ever could. At the moment, Volkswagen's most advanced electric drive systems operate around 89% efficiency, while Tesla's best production vehicles reach roughly 90 to 92%. Ford's F-150. Lightning performs lower in real-world conditions, particularly in cold weather. If Geely's 93.8% claim eventually survives independent testing, it would move the benchmark noticeably higher than today's leading production EVs. The business side tells an equally interesting story. Volkswagen's sales in China have dropped dramatically over recent years, and the company is now working with Chinese EV manufacturers to accelerate future software development. General Motors has reported billions of dollars in EV-related losses, while Ford continues adjusting its long-term electric vehicle strategy. Even Tesla, once the undisputed leader of the EV market, has seen BYD overtake it as the world's largest EV manufacturer, while Tesla's share of Chinese EV exports has declined significantly. These aren't isolated headlines. They're signs of an industry that's changing faster than many expected. But before anyone declares a winner, there's one important reality check. No independent Western laboratory has yet fully verified Geely's flagship efficiency claim under EPA or WLTP testing standards. That means the final number could stay close to 93.8%. Or it could end up lower once additional testing is completed. Right now, nobody outside those future test labs knows for certain. However, one thing doesn't depend on that single percentage. The 16-in-1 integrated architecture is real. The reduced component count is real. The simplified wiring is real. And lowering manufacturing complexity almost always helps reduce production costs over time. For buyers, that could mean more affordable electric vehicles over the next few years, especially in markets across Europe, Latin America, Africa, and Southeast Asia where Chinese brands continue expanding rapidly. For American buyers, tariffs may slow that impact for now, but global competition doesn't stop just because one market builds a wall. The next 3 years could determine whether Western automakers develop competing technology or spend even longer trying to catch up. So maybe this story isn't really about a silver box. It's about a question the entire automotive world is asking right now. Did Geely just reveal the next chapter of electric vehicles? Or simply deliver the most impressive demonstration the industry has seen in years? The answer won't come from a press conference. It'll come when independent testing begins. And that's when we'll discover whether 93.8% becomes the new standard, or just another bold claim that couldn't survive the real world. Thanks for watching. Now the real question is, if you had to spend your own money today, would you trust the familiar badge on the hood, or take a chance on the new kid that's making billion-dollar companies sweat? Let me know in the comments. I read them all. Well, except the ones that say first. If you enjoyed this breakdown, hit that like button, subscribe, and I'll see you in the next one with another story the tech world doesn't want you to miss.